Welcome to Sundar's lecture, and in this lecture, this is lecture number, actually this is lecture number 23, and in this lecture we are going to take another example. Example number 3, right? I will write here example. I think we have taken already 3. This is example number 4, right? Anyhow, so what are all the topics we have seen in the last class? See, we have taken an example problem with dependent sources, and we have found what is the short circuit current. That means these two ends were short circuited when compared to the previous problem. In the previous problem, we have open circuited this two ends and we try to find what is VAB, right? This is that example. See, we try to find what is VAB, and in this problem we have found what is ISC using KCL, KVL and dependent sources background, right? So now in this class we will take another example. Let it be example number 4, and this is the question given. See, this is very simple question, but you have to find so many things, right? So if you see this looks like it is very simple, but anyhow you need to find power delivered by the 15 volt source, that means independent source, and what is the value of R1 and R2, and they have given what is the voltage across R1 and what is the current through R2. So that you can easily find, right? This is the independent source, that is 15 volt, and this is the dependent source. And what is this dependent source? This is actually a current source. You see a diamond shaped symbol is given, and inside that there is an arrow mark. So obviously this is a current source, and this current depends on I, right? I, which is what is I here? First branch, that means R1 resistors current. So this is current dependent current source, that you have to understand. Anyway, we will write the expressions now. So what is the first question? Power delivered by the independent source. So power delivered by the independent source means which is independent source? This is independent source, 15 volt source. So I will write down the formula first. P 15 volt has to be found. So what is the P 15 volt? See, already what is the formula for power? Power is equal to V into I. That we know already. So here they have given you already 15 volt. So voltage is given, and what is the current coming out from this 15 volt source? That is I. So obviously this value will be 15 into I. 15 into I. So if we find what is I, then we can easily find what is the power delivered by 15 volt source. That is the first question, right? So let it be equation number 1. Let it be equation number 1. And what is R1? See, R1 is the resistor connected in the first branch. First loop. So what is R1? How we can write R1? We know that current through the R1 is I, and what is the voltage across R1? That is already given, that is 9 volt. So if you need to find what is R1, see R1, what is the formula for resistor? V by I, right? What is V here? 9 volt given, 9 volt given, divided by what is I? What is the current through this resistor? That is I given. That is given as I. So you need to find I. If you know I, then obviously what you can do? You can easily find what is the R1 resistor. Then we go for R2, right? That is the next question asked, right? So R2 you need to find. See, the formula is same. What is that? V divided by I is the formula. There is no difference. So divided by, I will write here anyhow, divided by. See, what is the current in this resistor? That is already given, that is 34 amperes. So you can directly write this is 34 amperes. There is no issue with that. But what is the voltage? See how these resistors are connected. This resistor, this R2 resistor is connected between point A and point B. Which means what is the voltage? Voltage between these 2 points. If you know what is voltage between these 2 points, then obviously we can find what is the voltage in the resistor R2. Like that, 9 volt, which is nothing but the voltage between these 2 points. These 2 points, that is 9 volt. So you need to find what is the voltage between these two points. So I am writing that it as VAO, right? So this is expression number 3. So if we find what is I and VAO, then we can find what are all the uh, parameters. That means unknown parameters, 15 volt power delivered by 15 volt R1 and R2. So this is our ultimate aim. We have written what is the ultimate aim to find in this problem, right? Now we try to find what is I or what is VAO, all these kind of things. And now we see what we can do now. I can write the KVL at this loop. I can write KVL. See how I can write the KVL, since you see I will mark down anyhow. I will mark down. See, this is A, already they have given this is A. So what I will do, I will write this as B, already this is A, this is O, and this is C. I will write like this. Since this is given in the question, I have not changed these 2 points, right? So what I can do now, I will write KVL. I will write KVL at B, A, O, C loop. That's all. That I am going to write. Right? If I write KVL, what will come? See, I will start from this point, I will go like this, and then I will come to this point again, right? So start from this point, you go in this way, because you have to go in this way, because the current is given in this direction. So you have to go in this way. So if you go like this, so I am traveling from minus to plus in the voltage source. What is the value of voltage? That is 15. So what you will do, that is nothing but this is plus 15 volt, no problem. So then I will go in this way. See, here you don't see R1 because they have given you voltage here, right? So it is not necessary to see R1, because at KVL we always try to write what is the voltage, right? So we know what is the voltage in this branch. What is that voltage? That is 9 volts. So I am going in this way. So if I travel from plus 2 minus in the 9 volt source, what I can write, that is nothing but minus 9, right? Minus 9. Then you see I am traveling from this point to here, right? So this is what? This is nothing but this branch voltage is VAO. VAO. Always see, this is plus, this is minus. That is already given, right? This is plus, this is minus. So if I am traveling from plus to minus in VAO. So what I can write here? Obviously, I can write minus VAO, right? Minus VAO. That's all. That's all. There is no any other elements present in this particular loop. So what I can do? I can write this is equal to 0. See, this is the expression we have written now. So it is very simple to find what is VAO, right? So keep VAO to the other side. That means draw back this VAO to the right hand side. So what you will get? So I will write directly. So VAO should be equal to, if I bring this to that side and this to that side. So 15 minus 9 will give you 6 volt, right? 6 volt. So this is the value of VAO. Simple. Now you substitute in this expression to get R2, right? So it is very simple now. R2 you can find now. So R2 will be equal to 6 divided by 34. That's all. 6 divided by 34. So that this is found. R2 is found. Now you need to find what is I, right? You need to find what is I. So how you can find what is I now? See, I will write here, apply KCL, Kirchhoff's current law at this point, node A. This is node, right? 3 branches are connected, right? So obviously this is node. So KCL at node A. A is a node. A is a node, since there are 3 branches connected. So you apply now. So what you will get? So you have to put equal to symbol. You have to put equal symbol. What is the current coming here? I is coming towards this node, right? See, I is coming towards this node. So I have to put it in the left hand side. Okay. See, in this branch, 34 amperes is going away. So I have to put it in the right hand side. 34 amps is going away. So I have to put it in the right hand side. See, this current, that means 0.7 I, that is coming towards the node. towards the node, right? So I have to put it in the right hand side, left hand side, plus 0.7i. See, very simple. We have written, right? That's all. That is the KCL. So if you further simplify this, what you will get? So if you add these two, you will get 1.7i. That should be equal to 34, right? So if I simplify this, so what I will get? I is equal to, so I is equal to 34 divided by 1.7. That is nothing but it is 20 amperes. So see, we have found I. Using KVL, we have found what is VO. Using KCL, we have found what is I, right? So now what you can do, you can substitute in these two expressions so that you will get what is power by 15 volt, power delivered by 15 volt, and what is R1. Simple. So what you do, you substitute I is equal to 20 amperes in 1. If you substitute in 1, so what you will get? P by 15 volt should be equal to 15 into what is I, that is 20. So that is nothing but it is 150 and it will be 300, right? So 300 watts. So P by 15 volt will be equal to 300 watts. 300 watts. So this is the third question asked. That means this is the third question, that is R2 we found. This is first question, right? This is first question. That is nothing but P by 15 volt. Now what you do, you try to substitute. That means I is equal to 20 amperes in expression number 2. So if you substitute in expression number 2, that means R1. What is R1? R1 should be equal to 9 by I. What is I? I, which is nothing but it is 20. That's all. That's all we have found. That's all we have found, right? So I R1 is equal to 9 by 20. 9 by 20 what? This is ohms. And also this is also ohms. So you have to write SI units then and there, right? So this is the third question. This is the, sorry, this is not third question. This is actually second question, right? So see, we have found all the values, right? We have found what is what is P by 15 volt, power delivered by 15 volt, that is nothing but 300 watts. And what is R1, which is nothing but 9 by 20 ohms, and what is R2 will be, which is nothing but 6 by 34 amperes. So this is how you have to approach these kind of problems. See, you apply KCL and KVL wisely. See what are all the things you can which means you see where is the voltages are persist, then you apply KVL for that particular things, and you see where are the currents, we can easily write the current equation, there you can apply Kirchhoff's current law. You have to use, or you have to think wisely to use Kirchhoff's current law and Kirchhoff's voltage law. That is the ultimate aim. See, the practice will give you more clarity about KVL and KCL. Fine. Okay, you go through this problem and again we will solve another problem in the next class, so that you will get a clear idea about KCL and KVL as well as the dependent sources. I have already told you in gate questions mostly dependent sources problems were asked. So we try to solve many more problems in the upcoming lectures. Thank you. Have a nice day.